So for those of you who are watching the video, we are now in class, and we are continuing separable differential equations. Now, you know that sounds really so horrible, and you can go around and tell people you're learning how to do separable differential equations, and because you can't even say it. Now, remember, a differential equation just means it's a derivative. That's what a differential equation is. Separable means we can separate the parts. We can get the y's and dy together on one side and the x's and dx together on the other side. And we're trying to find the function whose derivative is this and has this point on it. And remember, that's called an initial condition. All right. Remember, Leibniz, our dear old friend, Leibniz said my notation, dy dx, is not meant to be a fraction, but we can pretend it is. So, if we, and you can do this in one step, so hold off, don't write quite yet. If we multiply both sides by dy dx, then we get x to the fourth times y minus 2 dx, right? Well, I have the x's and dx on one side, but I still don't have the y's with the dy. How can I get it that way? Do I? Yeah. So what I'm going to do is I'm going to do 1 over y minus 2 dy equals x to the fourth dx. You could have done that straight from here. So the way I would have done it is I would have looked at that and said, okay, I know I got to move the dx, but this y minus 2 needs to go over with the dy, so I've got to divide by the divide by the y minus 2. So this is 1 over y minus 2 dy equals x to the fourth dx. That's what you're going to write down. Now we're going to integrate both sides. I want you to integrate the right side first. What do you get? Perfect. I get 1/5 x to the fifth plus constant. Now, let's think about the left side. What can I take the derivative of to get 1 over y minus 2? What? A frickin' log. All right, so let's do a little background work. What is the derivative with respect to x of the natural log of x? Remember, it's 1 over that times the derivative of that. Ladies and gentlemen, when you have a fraction and that bottom, that denominator, has a degree of 1, you're going to have a natural log. What is the derivative of the natural log of x squared? Well, it's 1 over that times the derivative of that, right? And then you simplify. What is the derivative with respect to y of the natural log of y plus y minus 2? Well, it's 1 over that times the derivative of that. But what's the derivative of y minus 2 with respect to y? So that's how we get 1 over y minus 2. So this is a natural log. Now you also have to put absolute value. If you can deal with a natural log problem, you can knock every one of these out of the park. This is going to be as tough as they get with the natural log. I have 2 questions for you. Number 1 is, why do I have to do absolute value? Good. I cannot take a natural log of a negative number. Number 2, you notice I'm doing indefinite integrals on both sides. I put a plus c on the right side. Why didn't I put a plus c on the left side? If I integrate the left side and I get natural log of y minus 2 plus a constant, and I'm going to call it C1, equals 1/5 x to the 5th plus C2, a different constant. What if I subtract this constant from both sides? What's a constant minus a constant? Another constant. That's why we're just going to put one of them. This one, this C right here, takes into consideration what would have been on this side as well. Okay, now let's use our initial condition to figure out what C is. F of 0 equals 0. Well, that ought to not be too bad. That gives me the natural log of 2 equals C. Well, snap. No, that's not my answer. All right, so I've got natural log of absolute y minus 2 equals 1/5 x to the 5th plus natural log 2. Now, I promise this is not as ucky as you're going to think it is. There is a technique that we can use to get rid of the natural log. Let me remind you of something, huh? What? No. What's that? It's 3. Why is that 3? Because they have the same base. If you remember back in the day, which means before this course, that's 4 raised to the log base 4 of 2. If this base and this base are the same, then those things are inverses. They cancel each other out, and you are left with 2. What's the base here on natural log? E. That base and that base are the same, so the answer to that is 3. 3 equals 3 equals 3. So, now this is, again, this is going to look funny. But what I'm going to do is I'm going to take both sides of this equation and I'm going to do this. Oh, it certainly is. I'm doing the same thing to both sides. I have a question for you. If A is equal to B, is 2 to the A power equal to 2 to the B power? Uh-huh. That's why that's true. Now you think, okay, you made that look worse than it was when it started. But this cleans up so nice. Left side, those bases are the same. What's that left side? Absolute y minus 2. Now let's see if you remember something. What's x squared times x cubed? X to the 5th. What's x to the A power times x to the B power? X to the A plus B. Oh. When you have an exponent that's added together, then that came from so what I'm going to do is I'm going to rewrite this as e to the 1/5 x to the 5th times e to the natural log of 2. But we raise the roof because we know what e to the natural log of 2 is. You're sitting too close to me to be saying that stuff. So what I know is absolute y minus 2 equals 2 e to the 1/5 x to the 5th. That's not bad, huh? That's not bad at all. That's not, I don't think it's bad. I am showing you, I'm just showing you how to do things that look harder using stuff that you already learned. Yeah, well, all right, I'll give you that one. Now, what we got to do is we got to figure out how to get rid of those absolute value bars. My natural log. Let's answer that. What number or numbers have an absolute value of 3? I got rid of the absolute value bars by doing what? Plus or minus. Huh? So, y minus 2 equals plus or minus 2e to the 1/5 x to the 5th. Ha ha ha! Mm-hmm. No. Stop. I think you're hurting my feelings. 2e to the 1/5 x to the 5th plus 2. What does it matter? It looks cleaner. Yeah, you put it in front. You put it in front. But now remember, I'm not finished because this gives me 2 different answers. Only one works. What happened to C? I figured out what C was way back up there. F of 0 equals 0. Now is when you use your initial condition and see which one works. No, they don't both work. I promise you they don't both work. 0, 0. 0 equals plus or minus 2e to the, if x is 0, what's that exponent? What's e to the 0 power? 1. 0 equals plus or minus 2 times 1 plus 2. Which one works, the plus or the minus? The minus. So your answer is y equals negative 2 e to the 1/5 x to the 5th plus 2. If you can get through that, you can get through any of them. You say, yeah, well, that's very questionable. That's just one problem. Okay, let's try another. Wrong! You can do this. Have a test over natural log? One problem, huh? One problem. Now, let me tell you what. There will be, you just count on it now, there will be a problem like this on a free response on the AP exam, and it will be worth either 5 or 6 of the 9 points on that problem because there are so many steps, okay? Because there are so many steps. You knock this out of the park, you got 5 or 6 points on a free response. Whose phone is that? Is that yours? Okay. All right. Now, number 6. We got to separate the variables. Let's cross multiply. Because I cross multiplied. It doesn't go there, does it?
Because if we're not suffering, we're not learning.
You really need to sit in the back. No, he's really not. Oh, thank you, thank you. I'm going to have to divide by x squared, and I'm going to have to divide by y minus 1. So what I'm going to have here is 1 over y minus 1 dy equals 1 over x squared dx. Now I have separated those variables appropriately. The x's are with the x squared, the y's are with the, excuse me, the x's are with the dx and the y's are with the dy. Do you have any questions about how we got there? Caitlin's just sitting back there holding her head. Okay. All right, integrate. What's that left side? Natural log of absolute y minus 1 equals, ladies and gentlemen, please, 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 if you call that natural log of x squared, I'm just going to just fall down right here. That's x to the negative 2. How do you integrate x to the negative 2? What's the antiderivative? What do you do to the exponent? So what is it? That's it. Negative x to the negative 1. Now, what's another way we can write this to not have a negative exponent? Negative 1 over x. Let's write it like that. Plus a constant. And don't forget the c. Okay. I tell you, you better sit in the back, buddy. Now, we've got to get rid of natural log. How do we do that? How did we do it last time? How did we do it last time? E to the, now, e to the, now, listen, I'm not going to write another step. Here's what I'm going to do. I'm just going to throw the e in there like this. Oh, wait, I forgot to find the, hey, I got to do an initial condition first. F of 2 equals 0.
Oh, okay.
Right there, sweet pea. Natural log of let y equals 0. Natural log of 1 equals what's the natural log of 1? Yes, you do. You're thinking e to the what power is 1? 0. So c is a half. Okay, so you got that part, that c is a half. So now I've got natural log of absolute y minus 1 equals negative 1 over x plus half. Now I'm going to do e to the these bases are the same. What do I get? Yep, I get absolute y minus 1 equals, now, this is e to the negative 1 over x times e to the 1/2. right? I tell you what, let's make that easier. Let's leave it the way it is. Let's just leave it the way it is. Because e to the 1/2, there's nothing I can do to it. I mean, I can't make it nice except to say square root of e if I wanted. Unless I had a calculator, but I don't. Okay. How do I get rid of the absolute value bars? Plus or minus. So I'm going to have y minus 1 equals plus or minus e to the so y equals 1 plus or minus e to the how many answers do I have there? 2. F of 2 equals 0. I've got to decide which one of those has the initial condition on it. I'm just sitting here working. Mm-hmm. Which one works? The negative one works. So my answer is, hang on, 1 minus e to the, see you after lunch. On this problem, this is the last one in your notes, right? The author made a change on mine, so I'm assuming he wants to make the change on yours. He marked out this, I can't even read it right there, and he rewrote that as e to the y. So just make that an e to the y. So this is dy dx equals 3x squared over e to the y. Okay. Now, you'll notice this was from the year 2000, but yes, that was a long time ago, like the year you were born. Gosh. But the AP Calculus exam has been around since the 1950s, so. Okay. Here we go, but maybe longer than that. Let's separate our variables. So we're going to get, what, e to the y dy equals 3x squared dx. Now we're going to integrate both sides. Now we had this discussion, I believe, the last time we met. What's the integral of e to the y? E to the y. Because the derivative, if you're doing it with respect to y, because the derivative of e to the x is e to the x, remember? So this is just e to the y. You don't remember that. Why am I not surprised? No, integrate the other side. What do you get? Yep, plus c. Hope not. Now what? What is c? The point 0.01 is on this curve. Yes? So e to the y equals x cubed plus e to the 1/2. How do I get a variable out of an exponent? You take a log. Do you remember? Remember that? Pull that down as the coefficient. You did that in logs in Algebra 2. So what I'm going to do is I'm going to take the natural log of both sides. So I'm going to write natural log of e to the y equals natural log of, I want to do, yeah. What is that left side? It's y natural log e. But what is the natural log of e? 1. Now, I gotta think about something though. What I'm wondering is why the author did not put the right side in absolute value bars. Because, is there anything up here that says anything? Nope. Because that runs the risk of being negative, doesn't it? I think the answer ought to be absolute value bars there. I think it ought to be this. Because you cannot take the absolute value, or cannot take the log of a negative number. Now, we found the A part. Now let's find the B part. Oh, I know what he did. I know what he did. He took care of that. Let me show you something. He took care of this in the domain. Because if you notice, do you see the B part says find the domain in the range? So he took care of this in the domain. So that's why we're okay. Now when it says to find the domain, I can only take the natural log of what kind of numbers? So let's solve that little inequality right there. Real easy to solve. Subtract e to the 1/2 from both sides, because remember, e to the 1/2 is just a number, right? Because e is 2.7 something something. So the square root of that is just a number. So I've got x cubed is greater than so what do I know about x? Yeah. That's ugly, right? So as long as x is in this vicinity, then we know that you can take the natural log of it. So how do we write that in terms of a domain? How would we write it in interval notation, not with the braces and such that, and not all that garbage? We'd say cube root of negative e to the 1/2 to infinity. Simplify, I don't know if you can simplify it, but you can write it differently. Yeah, that would be, let's not worry about the negative. That would be e to the 1/2 to the 1/3. So you could say the opposite of e to the 1/6, and that would be fine. That's the same thing. And it asks for the range. If you graph natural log, just regular old natural log, it looks like this. What's the range? All real numbers. Yeah, range is all real numbers. That's it, isn't it? That's it. Okay, slope field. graphical representation of solutions to differential equations. This is what we pray is on the AP exam, because they are incredibly easy to do. The easiest way to do them is with a computer, but I've never done them that way. The pictures that you will see of slope fields have been computer generated, but I want to start with this. If I ask you to graph what's true about all those? Same slope, meaning they are parallel. So if I wrote something like this, how many solutions are there to that? An infinite number, right? They are parallel. If I drew them all, you know what they would look like. It'd be, right? Okay. A slope field is a pictorial representation of all the possible solutions to a given differential equation. When I wrote y equals x plus c, and I graphed a whole bunch of parallel lines with a slope of 1, that would have sort of been a slope field. Remember that a differential equation is the first derivative of a function. That's what a differential equation is. Thus, the solution to a differential equation is just f of x, or y. Okay. There's an infinite number of solutions to this differential equation. Show your work and explain why. Let's solve this one. This will go real fast. Let's solve it just like we finished solving a little bit ago. If dy dx equals x minus 1, let's find a solution. Remember, separate your variables. So you're going to have and if we integrate both sides, what do we get? That's it. Yep. Now, when you see the plus c, this is what we call a general solution. If you don't have the c, if you have an exact answer with no c in it, that's called a particular solution. So what we're going to be looking at is what we're going to be kind of looking, I don't know, you're just going to have to see one. Yeah, I know. Okay. When we did this one, what is the difference between this, the graph of that, and the graph of that? Is one more than the other one? So if you graph both of these, they're 1 unit apart, right? Anywhere you measured, they would always be 1 unit apart. They're parallel. Even on this equation, which is not going to be a line, it's going to be a curve. You'd have one curve, let's just say you had one curve like this, then you could have another curve like this, and another curve like this. All right. I don't know. Those are parallel curves because they will never touch. Now what we're going to do is we're going to draw a slope field. When you draw a slope field by hand, with the exception of this one, you're really not going to be asked to do more than 9 points. But a slope field is real easy to do. We're going to compute the slope for each point indicated on the grid at right. We're going to make a small mark that approximates the slope through that point. So let's take the point 0, 0. I want to know what is the slope of this, okay, of the parent graph of this. What's the slope at 0, 0? Well, remember, this is the equation of the slope, isn't it? Because that's what dy dx is. So what is the slope at 0, 0? Yeah, it's -1, isn't it? So I'm going to go to the point 0, 0, and I'm going to make a little mark, just a little tangent line that has a slope of -1. So I'm just going to go here and I'm going to do this. And that's all I'm going to do. A slope field is just a bunch of those. Let's go to the point 1, 0. If x is 1 and y is 0, what is the slope? The slope is 0. So at the point 1, 0, I'm going to draw this. At the point 2, 0, what is the slope? 1. So I'm going to go to that point and I'm going to draw a little tangent line that has a slope of 1, best I can do it. That's what you're going to do at all of these points, okay? And you are generating a piece of a slope field. So let's see if, can you do these in your head? 0, 1. What's the slope at 0, 1? 0, 1. -1. 0, 2. In this particular one, does y influence the slope? Not at all, because the slope just has an x in it. In this case, yes. Now here's what Sam said. So for all of these on the y-axis where x is 0, they're all going to have the same slope then, right? And the answer to that is yes, because y does not influence the slope at all. When x is -1, -1 minus 1 is -2. So here, you're like, I don't know how to make a slope that's -2. Just make a slope that's steeper than -1. Don't make it vertical. Don't make it vertical. That's what I'm going to look for. I'm going to look for, is this column right here steeper than this column right here? What about on here when x is -2? What's the slope? So again, make that steeper than this one. If you were able to generate thousands of these points, you would have a real good idea of what the graph itself looks like. And you would be able to draw a whole bunch of them that are parallel, okay? What do you think, just by looking at the little part that we've got? The slopes are real steep, then they get less steep, and then they get less steep, and then they go to 0, and then they start getting steep again. What kind of shape? That's a parabola. That's a slope field for a parabola. Now, what the AP... How?
Because it's x squared.
Because if you integrated, you get an x squared. Okay. I wasn't going to hit him. Do you really think I was going to? Oh my goodness. Now, on the AP exam, what they will do is they'll say, okay, graph the particular solution that goes through that point. Well, look, the slope field shows, okay, I've got a parabola there. I'd have a parabola here, a parabola here, a parabola here. Which of the parabolas is going to go through that point right there? Okay. Now, this is... This is kind of hard for me to do, and you don't have to be exact at it. But what you're going to do is you're just going to kind of sketch something like this. You see how I'm kind of touching some of those? So that would be the graph of a particular solution, particular meaning I am given a point on that curve. Sure, yeah, I should have gone lower. So, you know, I could have, I better? Next page. Given the differential equation below, compute the slope for each point indicated on the grid to the right. Look, we could separate our variables and we could come up with some kind of a general equation. But here's what we got. Here's the slope. The x and the y both affect the slope this time. Let's go to the point 0, 0. What's the slope at 0, 0? What's the slope at 1, 0? 1 minus 0. At 2? 2 minus 0 is 2. Just make that steeper than the one you have at 1. Now, we can't do what we did last time, which was say, oh, all of these on the y-axis have the same slope, because they don't, because we have x and y affecting the slope. What about at the point 0, 1? What's the slope at the point 0, 1? Negative 1. At 0, 2, it'll be negative 2. At 0, 3, it'll be negative 3. You will be able to start to see patterns on a lot of them. Are they? Okay. Sam's got an idea. Sam thinks that the slopes for the diagonals are going to be the same. What about right here? What about at the point 1, 1? What about at the point 2, 2? Well, let's see. That's a great question. We're just looking to see. What about here at negative 1, negative 1? That's also 0, isn't it? Negative 2, negative 2? Yeah, negative 1 minus negative 1. Let's go to this point right here. What are the coordinates of that? 2, 1? 2, 1. 2 minus 1 is 1. What about right here? What about at 0, -1, 1? At 0, -2, be 2. You get the idea of how to generate a slope field? I don't want to take the time and do all these points because that's a lot of points. But let's do a couple more. What's this point right there? That's -2, -2, 2. What's that going to be? -4. Boy, you need to draw that one almost vertical. Almost vertical. I'm going to show you kind of what the slope field looks like real quick. Because I just don't, huh? You got it carried away. All right. Here we go. That's what the slope field looks like. So if you'll notice, you see how it's real steep, not as steep, 0, then it's starting to increase again. So this graph, these parallels, they're going to go in and they're going to come back out like this. So real steep over here, but not as steep on this side. You can't draw a particular solution because you're not given a point. There's a slope field. Now, this is something that you could expect to see on the AP exam. You are given a slope field and you are given 5 differential equations. Which differential equation does that slope field match to? Okay, so let's just start talking. The easiest way to do these, I think, is to find something that I can start with, something that I can get my hands around. I can get my hands around those because on the x-axis, what are all of those slopes? 0. So is there a way, like at the point 1, 0, or at the point 5, 0, that I could get 0? You see any of those that would allow me to get a slope of 0? Really? Yeah. Let's see. With this one, x times y, would that give me 0? Would x times y minus y give me 0? Would the c give me 0? Would d give me 0? No. Would this one give me 0? All right, so, okay, we got it narrowed down, right? Then I'd look right there. What do you see there? Yeah. When x is -1, the slopes are 0. So like -1, 0, -1, 1, -1, 2. Would any of these work on that? Would A work? Is x times y always 0? Is x times y minus y equal to 0? Well, snap. Okay, x times y. It better not be. It better not be. What's x times y? -2 plus 2. Ha. Let's try another one. X times Y, -1 plus 1, bingo. Find something that you can get your hands around, okay? How would you explain? I would very simply, I would explain, I would say I saw that on the x-axis, when y is equal to 0, I could eliminate D and E. And when x is -1, the slopes are 0, so I was able to eliminate A and B. And now, I do want you to see something else. I want you to look right here in quadrant 1. What do you notice? No, I'm not going there. Never mind. Forget what I said. Okay. This would be a slope field that you would see, that you would be asked to generate on the AP exam. See how many points there are? What, 12? You're not going to have more than that. All right. 2004. Consider this differential equation. On the axis provided, sketch a slope field for the given differential equation at the 12 points indicated. Let's draw your slope field. If you're watching the video, I'm just sitting here muttering to myself. I'm writing down the coordinates of a point, and then I'm putting them into this to see what the slope is at that point. So that would be 1 to the 4th power times 3 minus 2. That's 1 times 1, which is 1. -1, 0. That's 1 times 0 minus 2. That's -2. -1, 1. That'd be 1 times 1 minus 2. That'd be -1. At the point -1, 2. That'd be 1 times 2 minus 2. That would be 0. And at -1, 3. That would be 1 times 3 minus 2, which would be 1. I think I messed up 1, didn't I? Yeah. That one's not right. 1, 3. So that'd be 1 times 3 minus 2. How in the world did I get -1? You okay with the slope field? It's a slope field. These were not even in calculus when I took calculus in 19, I'm not telling you when, 1983. Yeah, that was a long time ago. That's part A. Let's look at part B. While the slope field in part A is drawn at only 12 points, it is defined at every point in the plane. Describe all points in the XY plane for which the slopes are negative. How could I be assured that x to the 4th times y minus 2 is negative. Whatever number I put in for x, what's x to the fourth always going to be? Positive. So this is always going to be some positive number times y minus 2. Why? How come? Why? There you go. We know that y minus 2 has to be less than 0 because a positive times a negative is negative, which means y has to be less than 2. So describe all points in the xy plane for which the slopes are negative. It would be all points with a y value less than 2. Except when x is 0. Yeah, good. Except when x is 0. So we better say it this way. Y is less than 2 provided x is not equal to 0. Okay. There's one more piece, and that's part C. How much is in these notes?
Got another one of these.
And that's all? Okay. Let's do part C. Find the particular solution. That's what we just finished doing, right? I want you to do that. Work together. I'll do it up here. This is separating the variables. What's that? What's that look? If you get lost, you can look up here. Are you okay to start that way? All right. Once you're okay to start that way, then let's go. You work and I'll work and mutter to myself because I'll be talking to Chase Chandler. Okay? Chase, I hope you watch the video, buddy. Okay, that's going to be our initial condition is 0, 0. So it gives me the natural log of 2 equals C. Why do I feel like we've done this problem already? Have we done exactly this one? Natural log of absolute y minus 2 equals, I know we've done this problem. Plus natural log of 2. So, yeah, your previous set of notes, number 5, is this problem. Okay. So on our other notes, let's see what we have. We had y minus 2. Let's see, we had y equals plus or minus, no, 2 plus or minus 2e to the x to the 5th. Okay. So our initial condition is 0, 0. Zero equals 2 plus or minus 2e to the 0. E to the 0 is 1. 2 times 1 is 2. Which one of those works? The negative one. Now listen, don't leave this on your paper. Because if you write 0 equals 2 plus or minus 2, that is a false statement, isn't it? 0 does not equal 2 plus 2. So if you put this on your paper to do the work, then just go like this. Don't worry about taking the time to erase it. It's quicker to make an X through it. If you have an X through it, the AP graders will ignore it. So your answer will snap. The answer is the one with the negative. What's the matter? Okay. The answer is the one with the negative. I don't know what's the matter. Yeah, you name it, I'll say it. I don't know, to the fifth. There's the answer right there. Okay, well, you were 10 years old when this question came out. All right, we're going to do a slope field. How are we doing on time? We're doing not bad. Make yourself a slope field. Now notice your derivative is y minus 1 over x squared. Now I'm going to ask you a question on this one. What about when x is 0? Does it say that? Oh, x does not equal 0. Okay. So we're not even going to have those points, are we? Well, it's undefined. Yeah, well, it may be, yeah, maybe a cusp. So you need to find the slope at 9 points. One zero would be 0 minus 1 over 1, so that's negative 1. Two zero will be 0 minus 1 over 4. Negative 1 0 will be 0 minus 1 over negative 1 squared, which is negative 1. At the point 1 1, 1 minus 1 is 0 over 1, so that's 0. That's right, all the y equal 1s are going to have a slope of 0, except don't put anything on the x-axis because x cannot equal 0. And then 1 2, 2 minus 1 is 1 over 1 squared. 2 2 is 2 minus 1 over 2 squared. That's a fourth. And negative 1 2. That'll be 2 minus 1 over negative 1 squared. What did I screw up now? Did I screw that same spot up again? Huh? What other one? There's only one top right. Which else did I screw up? There's not another top right one. Oh, that one. I wrote 1 over 1 and then made it negative. I'm an idiot. This one, 2 1. An idiot. 2 1 2 2. Shh. Christmas. Is that better? Not necessarily. Okay. Part B, find the particular solution to the differential equation with this initial condition. I'm going to leave you to do that. I'm going to do it here, you do it, and we'll see if we can get the same thing, and you just have to make sure I don't make a dumb mistake again. Let's see here. What? We've done this one too. Was this number 6? Okay, so number 6 in your previous notes was this problem. And the answer with the plus or minus, 1 plus or minus e to the negative 1 over x plus a half. So that's what you're going to get if you work the whole thing out. And the 0.20, was 20 what we used earlier? So 20 was the same? So which one was it? Was it plus or minus? Oh. The author doesn't have an answer to the last part, so I don't know if he meant to leave it out or not, but let's take a look at it. For the particular solution described in part B, so this that we got, what is the limit of that function as x approaches infinity? Why do you think it might be 1? So this piece right here, as x gets huge, what's that piece going to do? That's going to get closer and closer to 0, right? So if this gets closer and closer to 0, what's this whole thing going to get closer and closer to? A half, right? 0 plus a half. So wouldn't this thing be getting closer and closer and closer to this? I think that's the limit as x approaches infinity. I mean, you can graph it and look at it, but I think this will be the answer right here. Remember, all you're doing is you're letting x get great big, okay? Folks, we did 2 lessons today.